College Algebra, topic 1.4. We want to factor this four-term polynomial. And we look for greatest common factors. Now we don't have a greatest common factor because we have a 2, 8, 3, and 12. There's no common factor but 1. And there are no x's at the end here. So we're going to factor out greatest common factors in groups. So we're going to factor out a 2x squared from these two. That'll leave us x minus 4. We'll factor from this group right here a greatest common factor of positive 3. And dividing this by 3, we get x. Dividing this by 3, we get negative 4. Therefore, now our greatest common factor for both of these will be x minus 4. So we now take that out, and we have x minus 4 times the 2x squared plus 3. And so this polynomial used to be these two binomials before multiplication. Okay, here, once again, we're going to take greatest common factors out in groups. The greatest common factor for these two would be a 2x squared. Now divide everything by 2x squared, we get x. Divide this by 2x squared, we get negative 4. Now, this part right here. The greatest common factor for here would be 3, but we also lead with a negative. The leading negative lets us know that it was a negative 3 that was taken out of here. So let's reverse this by dividing by negative 3. So negative 3x divided by negative 3 gives us positive x. And positive 12 divided by negative 3 gives us negative 4. So this used to be a negative 3 times x minus 4. Now the greatest common factor is x minus 4. So we'll take that out. And that leaves the factor of 2x squared minus 3. Okay. Now, these are binomials. The factor in binomials, this fits the type of binomial that's the a cubed and b cubed, where both of these terms have perfect cubes and there's a difference between them. If you have perfect cubes and the difference between them, you take the cube root of both terms, and that gives you your a minus b. That's your first factor. Then your second factor will be made out of a squared plus ab plus b squared. If your binomial was perfect cubes but separated by a sum, the sum of two cubes, then the factor for that, again, we take the cube root of both and we get a plus b. Then we take our a, square it, then negative outside of a times b, and then plus the b squared. So all of these are perfect cubes. So take the cube root of this and the cube root of this, and I'll follow this pattern right here. So the cube root of 8 gives me 2, the cube root of x to the 6 gives me x to the second power, minus the cube root of 27 is 3, and the cube root of y to the third power is y. This is my a and my b. Next, I need a squared plus ab plus b squared. A squared is 2x squared times 2x squared, which is 4x to the fourth, plus a times b is 2x squared times 3y, which is 6x squared y, and then plus b squared. 3y times 3y is going to be 9y squared. And this used to be a binomial times this trinomial. Number 5. This is made of cubes, and this side is made of cubes, so it does fit this right here with where you have the sum. So the cube root of x cubed gives us x. The cube root of 64 gives us 4. This is my a and my b. Next, I need a squared, which is x squared, then a negative. Then a times b is x times 4, which is 4x, and then plus sign. And then b squared, which is 4 squared, that's 16. And this binomial used to be a binomial times a trinomial.